PAR and LAI are important information for researchers studying biomass in a plant community, or canopy processes such as radiation interception, energy conversion, momentum, gas exchange, precipitation interception, and evapotranspiration. The easiest way to get this information is with Decagon's LP80 AccuPAR septometer. It measures PAR continuously with the touch of a button. It performs the complicated LAI calculations instantly. Tall canopies are no obstacle for the lightweight handheld device. Simply records several measurements of light outside the canopy and then several inside the canopy. The LP80 updates LAI information based on the average of incoming PAR data. Alternatively, leave an LP80 tracking PAR in log mode outside of the canopy while you make your under-canopy measurements with another LP80. Afterwards, use these data to calculate LAI. Short canopies, like cereal crops or grasslands, are also easy to sample, thanks to the external sensor. When it is connected, the AccuPAR displays both PAR readings simultaneously. Place the external sensor outside of the canopy while you use the main sensor at several locations beneath. You can also use the LP80 for accurate LAI data if your subject is a row crop or other discontinuous canopy. Since it is important to take into account the empty spaces between rows or clumps, take measurements of beneath canopy PAR that include the empty space between rows. You also have the freedom to dictate how many sensors are active in the wand, which is useful for smaller plants. Let's take a closer look at PAR and LAI to understand how the LP80 works. What is PAR? Photosynthetically active radiation is the amount of light in a given location which is useful for photosynthesis. The LP80 contains 80 sensors that detect the amount of sunlight in the 400 to 700 nanometer range of the spectrum. It displays instantaneous PAR constantly and offers practically unlimited storage for data. What is LAI? Leaf Area Index is a way to monitor canopy density and overall plant growth. It is defined as the average area of leaves at a given location divided by the area of ground beneath those leaves. LAI of bare ground is 0, while in a dense rainforest, LAI can have a value well above 6. The LP80 calculates LAI based on a series of equations, the components of which are shown on the display beneath the PAR value. Let's look at these variables. The fraction of incident radiation passing through the canopy is represented by the Greek letter tau. Mathematically, it is the ratio of PAR measured beneath the canopy to PAR above. Zenith angle is the angle at which sunlight reaches the canopy. The LP80 calculates this based on user input regarding the latitude and longitude of the measurement site, the date, and the time of day. Beam fraction, FB, is the fraction of light that strikes the foliage directly from the sun. On an average clear day, less than 85% of the light we can measure is straight from the sun. The rest is scattered radiation from the sky. Even the clouds reflect a significant amount of light. An accurate LAI measurement requires that we properly account for both the beam and the scattered radiation. On overcast days, the beam fraction is 0, so this variable is eliminated. Unless using the external sensor, it is important not to make measurements on partly cloudy days when the light changes frequently. Even if the clouds do not cross in front of the sun, their movement in the sky affects the LP80's calculations. Chi is the leaf angle distribution parameter for the canopy and describes the way light is intercepted by the leaves. This depends on the general orientation of the leaves. Chi value relates to the percentage of light that penetrates the canopy from a vertical angle compared to the percentage that penetrates from a horizontal angle. If leaves are mostly horizontal, Chi value is greater than 1. If the leaves are more vertical, the Chi value approaches 0. In the majority of canopies, the Chi value is around 1, with a wide distribution of leaf angles. Note that uncertainty in Chi does not necessarily result in uncertainty in LAI. As this graph shows, when the sun is 60 degrees from its zenith, there is hardly any error in LAI, however inaccurate Chi is. And if you can estimate Chi with an accuracy of 10% or better, the error in LAI will only be 5%, even when the zenith angle is 0. In other words, uncertainty in this variable is unlikely to significantly affect LAI data. In most applications, chi is set to 1. You can find more precise explanations and other information on our website. Go to www.decagon.com and in the Education section, select Leaf Area Index Application Notes. We are always available to answer your questions personally as well. Email us at support@decagon.com.